so killing English right now.
Okay, so we're done with our expressions unit. We are moving on to our solving equations unit. Okay, so when you're solving equations, you must show your work. There are no ifs, ands, or buts about it. You must show your work. If you don't show your work, you will not get full credit for a problem. So on an assessment, each question is worth 3 points. Okay? 1 point for the answer, 1 point for showing your work, and 1 point for checking your work. Okay, so a one-step equation is worth 3 points. Two-step equation is worth 5 points. Okay? A multi-step equation, if we get there, is worth 7 or more. Okay? So you have to show your work. If you don't show your work and you just give me an answer, you get 1 out of 3 points. That's 33% on the question. Okay? I do not care if you can do these using mental math. Okay? Because you're not going to be able to solve every single problem you do in math class using mental math. So I want you, this is more about the process than it is about getting the right answer. Okay, does everyone understand that? Mm-hmm. Cool. So we are going to start with solving equations. We're going to start with one-step equations. We're going to do one-steps all week. Our quiz will be next Tuesday. Okay, so our learning target for today, I can solve one-step equations involving addition and subtraction. So today and tomorrow is only addition and subtraction. Wednesday, Thursday. Is that is third day is a word? Wednesday and Thursday is multiplication, division, and then Friday we're going to do an activity that's got both of them. Okay? So I can solve one-step equations involving addition and subtraction. So our most important vocabulary term for solving equations is inverse operations. Okay? Inverse operations are two operations that undo each other. Okay? So, what is the inverse of addition? Subtraction. Very good. So then the inverse of subtraction would then be?
Addition.
Addition. So then the inverse of multiplication? Division. And the inverse of division? Multiplication. So even though we're not doing those, it's good to know those. So these operations undo each other. Okay. We're going to work with some properties of equality today. What we're trying to do, our main goal is to get our variable on one side and our constant term on the other. So your variable needs to stand all by itself. So whatever is happening to that variable, we are going to use our inverse operations to undo it. So we want our variable by itself and our constant terms on the other side. So again, the unknown must stand alone when you have solved the equation. So we're going to use the subtraction property of equality first. Subtraction property of equality says subtracting the same number from each side of an equation produces an equivalent equation. So our first example is x plus 3 equals 8. So what number plus 3 equals 8? 5. So, but how do I do that with solving equations? X is being added or increased by 3. So what's the opposite of adding 3?
You
Subtract.
3 and then 8 by 3.
Okay, so I subtract 3 on the left side and 3 on the right side. What happens is 3 minus 3 is 0. So these two cancel each other out and you're left with x. And the 8 minus 3 is 5. Okay? So one of the most important things I think about solving equations is checking your answer. Now, checking your answer is a way to ensure that you're never going to get a problem wrong. So what we do is when we get our answer, we plug that number back into our equation. So x plus 3 equals 8 when x equals 5. So whenever I see an x, I replace it with 5. Okay? So 5 plus 3 equals 8. And then actually do the operation between 5 and 3. 5 plus 3 is 8. So 8 equals 8. True statement?
Yeah.
Yeah. So we've checked our work. We know that our answer is correct because the left side and the right side are balanced. Okay, when we check our answers, that's what we're looking for. Our left side and our right side to be equal to each other. Okay, so we're going to start here with h plus 13 equals 21. The first thing I always do is start with my upside down t. Now my upside down t separates my left side and my right side. That reminds me, whatever I do on the left side of my equation, I also need to do on the right side. So h is being added by 13. What's the inverse of adding 13?
Subtracting 13.
So I'm going to subtract 13 on this side. If I subtract 13 on this side, I need to do it on my other side. So 13 minus 13, that cancels out. So what am I left with? H equals, and then 12 minus, 21 minus 13. Craig is putting up this.
8.
Double zero? No, double zero would be like this.
8.
Everyone agrees with Craig?
Yeah.
Okay, so h equals 8. Now when I check my answer, I rewrite the original equation. Then I substitute in my value for h, which is 8. Now I do the operation between 8 and 13. 8 plus 13 is 21. Does 21 equal 21? Do I care that you can do this using mental math? Nope, I don't care. I'm not worried about your answer. I'm worried about your process. And the reason I'm worried about your process is because when you get into 2- and 3-step and multi-step equations, you need a process to solve your problems, right? There are not many multi-step equations that even I can look at and know, oh, x equals 2 or x equals -1. Okay? So that's why we need to have a process, and that's why I grade the work. And I value the work just as much as I value the answer. Yes, Brooke?
On a test, would we have to put 21 equals 21?
Yep. Yep. This whole thing, this is exactly what a test question looked like. Okay. All right, flip your page. C plus 7 equals a -8. So draw my upside down T. Again, that separates my right side and my left side, reminding me that whatever I do on my left side, I need to do on my right side. So C is being added by 7. What's the inverse of adding 7? Subtracting 7. So I subtract 7 on the left and on the right. So 7 minus 7? 0. So what am I left with?
8.
Okay. So now, -8 and -7. Same sign, right? Okay, same sign, add. So 8 plus 7,
15.
what kind of 15?
Negative.
Now, even though it is -8 minus 7, I look at that minus 7 as a negative. So then I'm looking at same signs or different signs. And then that helps me I sing my song. Same sign, add, different sign, subtract. Take the sum of the larger number, then you'll be exact. That's why it's so important to look at positive numbers and negative numbers. Instead of addition and subtraction problems, positive and negative numbers when we're adding those together. Okay. So again, checking my answer. Rewrite my original.
Replace C with negative 15.
Yep, plug in my value of C.
Negative 8 equals negative 8.
And then actually do the operation between negative 15 and positive 7. Different signs, so we subtract our values. 15 minus 7 is 8. 15 has the larger absolute value, so my answer is negative. All right, do the last one. X plus 20 equals 65. Do that one on your own. Craig, do you have a question?
I was gonna ask if we could do this next one.
Yeah, do that one on your own, absolutely. So think about your steps. Upside down T, what's happening to X? Undo what's happening to X. Ready? Yes? Everyone?
Oh, nothing. I was just gonna ask if I could answer.
Oh, okay, go ahead.
So I did the T and then I did 20 minus 20, which is 0, cancels it out.
Okay, hold on.
And
Okay.
then
So why did you choose minus 20?
because you have to cancel it out and you have to make sure that they're correct.
Okay, so the inverse operation of
Yeah.
adding 20 is subtracting 20. Okay, go ahead.
And then do the same thing with 65, and 65 minus 20 is 45.
Okay, so 20 minus 20, that's 0, so you're left with x. Okay? And then 65 minus 20
It's 45.
is 45. So, when I do my check, rewrite the original, plug in my value for x, okay. 5 plus 0, 5, 40 plus 20, okay, so 65 equals 65. My check, check, and check. So again, it's about the process, not about the answer. About the process, not about the answer. All right, So, the next one we're going to do is the addition property of equality. Adding the same number on each side of an equation produces an equivalent equation. So we've got x minus 6 equals 12. The inverse or opposite of minus 6 is adding 6. So I add 6 to the left and 6 to the right because I want my equation balanced. 6 minus 6, that's our 0. That's what we're looking for. Okay. We want that x to be all by itself. And then 12 plus 6 is 18. So again, when we check our answer, we rewrite our original, and then when plug in x equals 18. So whenever I see an x, I'm going to plug in 18. 18 minus 6. Does 12 equal 12? Absolutely. Okay. Why do I check my answer? Okay, well, let's see if I do this. Right? Okay. Now when I go to check it, here's my original. Plug in what I got. True? No. So then I need to go back and say, oh, I did something wrong because my left and my right side are not equal to each other. Okay? So that's why checking your answer is really important. Okay? It's not because I want you to do more work. It's not because I want you to practice your skills. It's because I truly want you to do the math and do the operations so when you get to a multi-step problem, you know, all right, if I plug back in my value, I should get my right side and my left side equal to each other. If my right side and my left side are not equal to each other, I've made a mistake somewhere. I have done a 15-line math problem before, and when I checked it, it was wrong because I dropped a negative somewhere. So my answer was, I didn't either, my number somewhere was supposed to be positive and I wrote it as a negative or vice versa. So then I had to rip that page out and do it all over again. But I would rather do that than turn my paper in and get that problem wrong. Miss 7 points or miss 10 points, whatever it is that my teacher was going to, giving the value of that problem. So that's why checking your answer is really important. If you have the option, you have the ability to do that on a math problem, that's a really good idea, okay? So again, this, not true, we gotta go back, okay? All right, so here's our equation. Y minus 11 equals 23. Upside down T. Y is being subtracted by 11. So the inverse of subtracting 11 is adding 11. So we're going to add 11 to the left and add 11 to the right. A negative and a positive always makes 0, right? Negative 11, positive 11, that makes your 0. Bring down your y. And then 23 plus 11, 34. Okay, so again, when I check it, rewrite the original. Sub in my value. Do the actual subtraction. 4 minus 1. 3 minus 1. Don't just walk through the steps. actually do the math, do the subtraction, do the addition. Actually do that, because the chances that you will get it wrong are high if you just put, oh, I know, I just gotta plug this in and check, I'm done. Brody.
So where the 11 is on the original problem, will it always be crossed out?
You should always cross that out, because that should always equal 0. All right, here's our next one. Yes, dear.
Can we try this one on our own too?
Okay, we're going to try the third one on our own.
Oh, alright.
So n is being subtracted by 4. Inverse of subtracting 4. Adding 4. So negative 4, positive 4. Opposites always equal 0. Now with this one, I have a negative and a positive. So that means different signs. What do I do when I have different signs? Subtract. So 11 minus 4 is 7. 11 has our larger absolute value. So my answer is negative. So again, when I check, always rewrite my original. Sub in my value that I got from my variable. Same signs, what do I do? Good? 11 equals 11, right? Alright, P minus 61 equals 26. Go ahead and try this one on your own. P minus 61 equals 26. So use your model from the previous problems and think about what steps you have to take. I mean, we got P equals 87?
Yes.
Yes.
Okay. Okay. Your homework tonight is to do the rest of the problems. Okay, so 6 problems, right? Okay, so these 3 here, and then these 3 here. Okay, that's your homework.